Okay. Alrighty. So today, by the end of the lesson, you should be able to add, subtract. We're going to hold off on multiply, I think. Um, I want to see how we do a subtraction. And then solve problems involving properties of exponents. So here is what I would like for you to do. I am going to open up the group chat in 1 minute. So I want you to go ahead and type this out in the room chat, and then don't hit enter yet. We're going to waterfall our answers. Yeah, Maddie, I could see it. You're good. There are 3 words here. We have the word constant, we have coefficient, and we have exponent. So I want you to tell me, you're going to tell me what is the constant. So you can say constant equals whatever, coefficient equals, exponent equals. I'm going to give you 1 minute to do that. Don't hit enter yet. We're going to waterfall our answers all at the same time. So a hint, there is a constant, coefficient, and an exponent in this expression. All 3 are in this expression. All right. I'm going to give a countdown from 10, and then we can hit enter. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, let's see what we all think. Awesome. Look at all those answers. Good job. Very good. Awesome. Yes. Good, good, good. And of course, yes, Anya, the variable is x. Very good. Okay, so let's go over this. The constant, I underlined it in blue, so I'm going to circle it in blue. The constant is the number 2. So a constant is a number without a variable. Number without a variable. Constants can be added or subtracted, okay? They're usually at the end because we put our expression in order of our degree of exponent. So this one doesn't have an exponent, so it would be at the end. All right, now we've got coefficient. Coefficient is going to be 3 here. Coefficient is the number in front of the variable. Coefficients can be positive or negative. They can also be fractions like 2/3, okay, 1/2. That's okay, Stormy, no problem. We're just getting started actually. And then lastly, we have our exponent, and it's this tiny little 2 up here. Okay, we call it a power. Okay, this would be to the power of 2. So it raises an exponent, or a variable, I'm sorry, the exponent raises a variable to a power. Okay, so it is the number above the variable. Let's say, here's a challenge question. If I wrote 4x minus 1, what would my exponent be? What is the exponent in that expression? What do you think? Okay, Jonathan, so I thought people were either going to say 0 or 1. So what do y'all think? Is it 0 or is it 1? Think about if I just have an x. What's the coefficient of just x? It would be 1, right? This is 1x. When you have a variable and the exponent is not written out, but the variable is still there, it has an exponent of degree 1. Okay, anything to the 0 power, so let's say I had x to the 0, that actually equals the number 1. Same thing even if I had like the number 100 and I raised it to the 0 power, although that looks like 100 degrees, doesn't it? It would still be 1. So if you have a variable that is written out, that means it exists. okay? The exponent is 1. Same with the coefficient. If it's just x, it still has a coefficient. We just don't normally write it. The coefficient is 1. Okay, so today we are going to talk about some of these vocabulary words. We've got constant, which we just talked about, coefficient, we talked about variable, degree, distributive property, like terms, simplify, and then the 4, monomial, binomial, trinomial, and polynomial. We're going to go ahead and start with our polynomial definitions. So a polynomial, okay, it means I'm going to have one or more terms. Okay, monomial, mono means one. So here I have one term. What do you think binomial means? Like a bicycle. How many wheels does a bicycle have? 2, exactly. So it's going to have 2 terms, 1, 2. So then a trinomial, like a triangle, has 3 sides. Tricycle would have 3. Yeah, exactly. Tri equals 3. So it's going to have 3 terms. And then a polynomial, what do you think a polynomial is? We went over it in the review video or the lesson yesterday. So a polynomial, you're close. Yeah, Angel, you're on the right track. It's just an expression of 2 or more algebraic terms. So we've got, instead of it being like a number plus a number, so 4 plus 1, we have an algebraic term y plus a number. So 2 different terms, polynomial. And they can be always just 2. It's 2 or more. Was there
Miss, I have a question.
Sure.
Okay, so I was doing the work from yesterday, all right? So you know how you told us when subtracting we put a 1 before the minus, and then like while we're doing the
Distribute.
yeah, while we're distributing it. Okay, so what happens if we have like an x that has a power of 3 or something? Does it turn into like a positive or like a negative
Okay.
x?
So good question. You're asking if we had like this. So we have some term, let's say a polynomial. Let's just say y plus 1. And then you're saying we would have like y to the third plus 4. Is that what you're asking?
I'm asking.
So when we distribute, we're going to go over some of these and some problems, but I'll answer your question real quick. When you distribute, this is like a -1. That's exactly what you were saying. -1 times y to the third would become -y to the third. And -1 times +4 becomes -4. Exactly.
Okay, so if there's like an x or y in there, it just turns negative. It doesn't get the 1.
So it technically does get the 1. You're right. It does get the 1. We just don't normally write it out. But if you wanted to write -1 y to the third, that's totally fine.
Okay, I'm just making sure.
Yeah, good question. You just won't see that 1 in front of your variable. You won't see that on the STAR test, but it's not wrong if you put it. Good question. Okay, let's talk about degree. We kind of briefly mentioned this in the warm-up. The degree of a term is the value of the exponent. So for example, 4x squared has a degree of 2. The degree of a polynomial, so just an expression, also has a degree. So exponents have a degree, each term can have a degree, and then the entire polynomial can have a degree. The degree of the polynomial is going to be the highest degree term. So for this example, 3x squared plus 2x plus 5, this first term, 3x squared, has a degree of 2, 2x has a degree of 1, and then 5 has a degree of 0. So we take the highest degree, which is 2, and we say, okay, this would be a polynomial of degree 2. Alrighty, so standard form of a polynomial is written in order of highest to lowest degree. We kind of talked about in the lesson video yesterday and in small group, we talked about you don't necessarily when you rearrange your terms. So if you took two terms that were like terms, we rewrite them and we're going to put the highest degree at the front. Again, it's not wrong. These two polynomials here, they're the same thing. They mean the same thing. They represent the same thing. One is in standard form and one is not. I think it's easier when you write in standard form because then you can make sure you've got all of your like terms. All right, so let's talk about adding and subtracting polynomials. I think based on your homework, your adding looked pretty good. So we're going to kind of move quickly through adding and spend the rest of the time talking about subtracting because subtracting can be really tricky. So when you add and subtract polynomials, you're always going to follow these 4 steps. Okay, so write these down. First thing you're going to do is rewrite in standard form. So make sure that your highest degree is first. Again, it's not wrong if you don't do this. However, when you don't do this, sometimes our organization gets a little goofy and we might have 2 terms, but they're not next to each other. So we don't simplify them and then we don't get the correct answer, or we might forget a term. I like goofy too, but I don't like when my answers are goofy. So you're going to rewrite in standard form. Then you're going to distribute to get rid of any parentheses. This is super important when you're doing subtraction, especially, okay? Next, you're going to combine like terms. So I know for some of you that phrase is a little bit confusing, combine like terms. You're going to use the signs that they give you. So it's either going to be a plus sign or a minus sign, okay? So combine like terms just means you're either going to add them together, you're going to subtract. Then you're going to simplify. That just means you're going to add. So like 2x plus 2x would be 4x. Simplify means to just write 4x. Okay? All right. And then important, super important. In order for you to combine like terms, we have to know what a like term is, right? So a like term means that the variable and their exponents are exactly the same. Exactly the same. Okay, we kind of talked about this, and we sort of went through this with solving equations in last semester. Just like if we have 2 plus x, we can't add those together. That doesn't become 2x. It's just 2 plus x. Those are not the same, so those would not be like terms. However, if this was 2x, so 2 x's plus 1x, 2 plus 1 would be 3. Okay. All right, now I'm going to close the group chat for just a second. Here's another slide about like terms. When adding, remember you can only combine the like terms. Same with subtracting, okay? So this means the bases, base is another word for variable, okay? So you have to have the same variable and the exact same exponent. So let's take a look at these. I'm going to cover some of these up so it's less busy. Alrighty. 3x squared plus 4x squared. Those will combine, okay, because let's check. Do they have the same variable, x and x, same exponent, squared and squared? Yes. So combine means I'm going to look at the operation that's happening. It's a plus sign. 3 plus 4 is 7. And then you keep your base and your exponent. When adding, you just keep the base and the exponent. We're going to add the coefficients. Grace, that's a good question. Grace asked, when subtracting, if the number's already negative, does it turn into a positive? So you still have to do the subtraction sign. If you're subtracting a negative, then it will turn into a positive. So I'll show you what that looks like here in just a second. All right, 3x squared plus 2y squared. This would not combine. Why does this not combine? I'm going to open back up the group chat. Why do 3x squared and 2y squared? Why can we not combine those? Good. So the exponent's the same. But exactly, the variables are different. Perfect, good job, different bases. All right, now we've got, tell me about this one, 5x squared times y plus 7xy. Why do those not combine? They both have an x and a y.
Well, they
Good.
don't combine because there's the exponent in one of them.
Yes, exactly. Very good. So the exponents are not the same. Base is the same, exponent is not. And then lastly, we've got 4x squared y minus 1x squared y. So we check our exponents. Are they the same? Sorry, we can check our variables first. We have x and a y, x and y, x squared, y, and y. So those would combine. And we just follow the sign that's in the middle. We combine them by doing whatever operation is already written. So 4 minus 1 becomes 3x squared y. All right, I am going to turn the chat off. We need to stay on math. Okay, guys. So give me a quick, I'm going to do this with you, but if I have a volunteer that would like to try to write this on the board, awesome. Whoa, lots of volunteers. I love it. Okay, Caitlin, I'm going to have you write this on the board for us. Everyone else is going to do this on your own. This is the only addition one that I have for us today because you were doing so well with it and I wanted to get to subtraction. Okay, so let's go ahead. You're going to do this one on your own. And we have a few more problems of subtraction. So volunteers, if you want to volunteer, there'll be a couple more opportunities. Yeah, good, Ward. Very good. Check your last number, actually, Ward. So something I like to do, Caitlin, you're doing a really good job. You keep going. I'm just going to show the class something that I like to do. I like to either draw a shape around all of the like terms, or I like to, I saw a lot of you using colors. I love to use colors. So colors in Class Kick is really awesome too. So something that I might do before I start rewriting is I would say, okay, let me find, this is x squared. Let me highlight in blue all my x squareds. And then I would say, hold on one second, Erica. And then I would say, okay, this is plus 4x. Here's another x. And then my constants, so 5 and 1. So now I know, okay, I'm going to combine the blues, combine greens, combine reds. Okay, Erica, did you have a question?
I have another way you can do it. I just do, it's like 6x squared. I just find any matching one that is like the combination of it or something, and then I just add it and then put it down and then go to the next number.
Yeah, you can do that.
One, put it down, so it could just be easier to.
You can do that. When you start to get a little bit longer, it's a little bit more difficult to stay organized. So that's why Caitlin did a great job solving this. But real quick, I'm going to go through it and these steps. So I'm going to rewrite this in standard form. So I know that I'm going to combine my blues together. There was a question about, can you combine from other parentheses? Yes, you can. When you're adding, especially, it's very easy. You're just adding 6 and 2. Okay, we're going to go over subtraction where you're first going to have to distribute your negative before you can combine them. Okay, but yes, you totally can. So if you think about our order of operations from way back when, PEMDAS, we see if we can combine anything in parentheses first. If we can't, we move on. Okay, and then we want to make sure that each of the parentheses is written in standard form so we can easily see it. So what we have here, Emmanuel, can you send that to me in an email? We have 6x squared plus 2x squared. Those are my blue terms. Then I have 4x plus 3x, and then 5 plus 1. Some of you, like Erica was saying, you skip this step because you can kind of do it in your head. And if you've already circled or colored or highlighted your like terms, then that's okay. We just have, I really want to encourage you, Ward, there is no A10 today, okay? It's just a video. I want to encourage you to find a way to organize your like terms, okay? So 6x squared plus 2x squared becomes 8x squared. 4x plus 3x becomes 7x, and 5 plus 1 becomes 6. Okay, how do we feel about this? Green is like, yeah, addition's great. Red is like, I'm going to send you an email. If you're red, I want you to send me an email so that we can meet and go over this together. And yellow is like, I think I got it, but maybe just a little more practice. And there's lots of practice problems on your homework. Okay, good. I'm glad it makes way more sense. Leilani, that's a good question. Leilani is asking, can you combine like terms if one's positive and one's negative? Absolutely. So what you would have, let's say, Leilani, let's say you had negative 6x squared plus 2x squared. It's just negative 6 plus 2. It doesn't become a negative unless the negative is on the bigger number, okay? Negative 6 plus 2 would be negative 4. So you can combine them. It's not always positive. It's not always negative, okay? It's just adding and subtracting. Sometimes we get a little bit confused on our negative numbers, like adding and subtracting negatives. So when in doubt, just put it in your calculator. That's what you have a calculator for, so let's use it, okay? All right, so now I'm going to do this first subtraction problem with you. I'm going to show you, it's not a different way. It's the same way, but some people like to write it differently. So what I want to talk about with subtraction is this negative sign here. This is saying that everything in this first set of parentheses, we're going to subtract everything here. So we have to subtract 2x, we have to subtract 3x, we have to subtract 1. Okay, so this is where the distributing in step number 2 comes into play. It's easy for us to remember, oh, 6x squared minus 2x. That's easy. But then our mind likes to just say 4x plus 3x, 5 plus 1. We forget that we're subtracting everything. There's 2 ways you can do this. The first way is to just say, okay, I'm going to distribute, which means I'm going to take my minus sign and turn it into a plus, and I'm going to flip the signs of everything in the parentheses. So these were all positive, so now they all become negative. You can just flip the sign and go from there. The other thing you can do, I'm going to write it up here. Some of you might like to actually see the distribution happening. Is you can, just like our distributive property from the first semester, you can go ahead and multiply it out and then rewrite it. So then you could write 6x squared plus 4x plus 5 minus 2x squared minus 3x minus 1. Some of you don't mind to have the plus negative 1. That makes sense to you. It's faster. That's fine. If you are someone that likes to have the minus signs there, I would suggest rewriting it. Okay, so you can do it either way. For those of you that like to have it written out, I'm going to rewrite this down at the bottom, and I'm going to put my like terms together. Okay, so before I do that, I'm going to highlight. I've got 6x squared and negative 2x squared. Don't forget to include the sign in front. The sign in front, whether it's plus or minus, tells you how you're combining. So like step 3 says combine like terms. Well, how do we combine them? That's what the sign tells us. We're either adding or subtracting. All right, so then we've got positive 4x minus 3x and 5 minus 1. So again, if you like to do colors, and you can move on to the next step from here, that's fine. For those of you that like to see them written together, 6x squared minus 2x squared plus 4x minus 3x plus 5 minus 1, I'll write that out for you. Okay, before I move on, does anyone have any questions about how I got to this expression, this step?
I in theory.
What's that, Richard?
I understand it in theory.
In theory. Okay. Well, why don't we, is it okay if we just keep going
Sure.
and you tell me where I lost you? So right now, all we've done so far is we've just distributed the negative to everything in the second set of parentheses.
You haven't lost me. I'm
Okay.
just concerned I'm going to forget all of this or somehow manage to mess it up the most stupid
that's
way
okay.
possible.
Because the way, I know it's easy to forget, and sometimes it's hard to remember some of these rules, but that's why we write it down in our notes, right? You're taking notes, yeah? Okay, that's why we write it down. And then in your homework, there's 4 practice problems for you so that you can practice it, okay? It's in yesterday's homework. Okay, so I had a couple people saying, can you re-explain? Or they're saying all the numbers in parentheses are switched. Yes. So every number that was in the original parentheses was positive. Because I'm subtracting, I had to distribute. Distribute means to multiply. I had to multiply all of them by a -1. There's an imaginary 1 outside of here. So this is -1 times 2x squared, -1 times 3x, -1 times -1. You can either distribute it doing the little arrows that I did up here at the top and rewriting your problem, or you can say, okay, if I know I'm distributing by -1, that means now I'm going to be adding, and every sign flips. So that's why I added a negative to each of those terms in the parentheses. Once you've distributed your negative, now it's the same, back to the same steps from when we were adding. Combine your like terms and simplify. So what is 6 minus 2? That would be 4. So we get 4x squared. 4x minus 3x. So 4 minus 3 is 1, or just x. So plus x, or you can put plus 1x. And then we have 5 minus 1, which would be 4. And that's your final answer. Okay, I'm going to give a couple more seconds for you to write this, finish writing this down. And then, Jonathan, do you feel comfortable? I know you still have your hand up. Do you feel comfortable to do the next problem on the next slide for us?
Yeah,
If
sure.
okay.
I don't mind.
Okay. All right, I'm going to go ahead and give you whiteboard permission. So Jonathan's going to do this next one on the board for us. And the rest of you are going to go ahead and work it on your own, and we're going to compare to Jonathan's. Okay? So remember, distribute that negative to everything inside. Okay, so Jonathan likes to just make it a plus sign and add negative numbers. If you don't like that, that's okay. I'm going to go ahead and do the distribution up at the top in case you need to see it written differently. I want to make note of something. The second set of parentheses is not in standard form. Okay, so if you want to rewrite that order first, you can. I definitely meant to do that. Let me rewrite it up here. If you don't rewrite it, it's not wrong, but some of you might have the habit of just combining the first 2 terms. Okay, so just be careful. if you did not rewrite it. All right, so now Jonathan has went ahead and combined his like terms. He's got them by color. And I'm still working on distributing, okay? Good job, Jonathan. Thank you. So I see you can check yours with Jonathan. I'm going to correct his. There's just one little mistake. Yes, Anya, I think you've seen. Oh wait, the -2 he got from -1 minus 1. So if you type that in your calculator, or if you just write it out, -1 minus 1 is the same thing as plus -1. So a -1 plus -1 is -2. Okay, so I'm going to pause. Everyone pause for just a second. Yes, Richard, you got it. Very good. When Jonathan combined the two red terms, so the x squared, he had positive 5x minus 6x. So that's -1x squared. That's perfect. Then we have 2x minus 2x. So what is 2 minus 2? 2 minus 2 is 0, right? So this is actually 0. We do not include that x term. It's gone, 0x. If you include that x term, that implies that there is one x still left, but there wasn't. So there are times when we have terms that will just disappear. Okay, there's a couple on your homework where one of the terms cancels out. Okay, and then again, -1 minus 1 is -2. So your final answer would be x squared minus 2. Okay, I know that was kind of a tricky one. That's why I wanted to do it with you. The 2x minus 2x, those are going to cancel out to be 0. Okay, good job, Jonathan. Thank you. Okay, let's try another one together. Let's see. Zachary, do you want to do this one on the board? I see your hands up. Do you mind doing this one for us? Awesome. Okay. I went ahead and gave you whiteboard tools, so go right ahead. I opened the room chat back up. Y'all can submit your answers when you think you've got it. If you see a friend that submits an answer and you're not sure how they got a term, or maybe you think it's incorrect, I want you to reply back to them and let them know where you think their error was. Or if you have a question and you're stuck, you can, in the room chat, say, oh, I'm stuck on combining these two terms. Okay, Destiny, send me an email. Okay, Dominic has a question. I'm going to read it out loud so that y'all can hear it. So when you do the multiplication of the variables, if one of them is negative, does it still have the same principle of negative times negative equals positive? Yes. So Dominic, that's a really good question. Let's say you had the negative sign and you had -2x minus 1. Exactly. So when you do -1 times -2, that would become positive 2x. Good question. Really good question. Okay, thank you, Zachary. All right, I'm going to go ahead and since Zachary did not show you how he distributed, he did distribute, but I'm going to just show you how you can distribute. You can use the arrows if you'd like. Okay, so that would give you 2x squared plus x plus 1 minus 3x squared minus 2. Or if you are someone who just likes to use the plus sign and flip your signs in the middle, that is fine too. Alrighty, I'm going to highlight my like terms. I just like to stay organized. I know some of you like to skip this step, but I just don't want you to make any mistakes when you're doing these on your own. And then x does not have anything to combine with. So positive 2 minus 3, that is going to give us a negative x squared. Okay, so we have negative 1x squared, or just negative x squared. Yep, that's perfect. I see some of you correcting that in the chat. That's good. My x did not have anything to combine with, so it just stays with me. And then 1 minus 2 would be negative 1.
I have a question.
Sure,
So
Erica.
what if you put just 1x squared on like this, like the final exam or something? Will it still count it as x squared, or you have to just put x squared?
So when you take your tests and quizzes in the course, they're usually multiple choice. So you just won't see that as an option. It will just be x squared. If you were to write 1x squared on your homework or your like part 2s of the test, your writing assignments, then that's totally fine. Okay, guys, I'm going to have to close the chat because we really have to keep it to math, okay? So it's not wrong. And especially if it's something that I'm grading, it won't be counted wrong. That's a good question. All right, here's what I want you to do. This is a released question from the STAR test last year. I'm going to put up a poll. I would like for you to answer this question. Let me rewrite these as A, B, C, and D. And then I want you to go into your class Kick, specifically the subtraction page. And if you need to make any revisions, let's work on that for the last couple minutes. And then at 10:45, I will go over this answer. Awesome. Good job, Mia. Thank you. Will you raise your hand? That way I can go in and grade it. Okay, awesome. I graded about 60 to 70 homeworks. So before you tell me that I didn't grade it, go ahead and check your grade in the grade book. If you did not get a 100, Angel, I can't check it right this second, but if you, I will later, I promise. If you did not get a 100, you can revise your homework. Okay, so I went through everyone's homework that submitted it in Class Kick. I checked every term. So if you got a term wrong, I highlighted it so that you don't have to redo the entire problem. Just check that term again. And then with the homeworks, anything that's in Class Kick, you can redo as many times as you want. So if you got a 2 out of 10, go in, make some adjustments, raise your hand again, and I will regrade it. Okay, the point of the homework in the Class Kick assignments is so that you can keep practicing and getting feedback until you get it right. Okay. All right, it looks like 32 out of 82 have answered. So we're still waiting on quite a few of you. Guys, I did grade. Alex, I know for a fact I put your grade in this morning, okay? So if you submit it and turn it in after 5 o'clock, it's not going to go in that day, okay? But I did submit yours. I put your grade in this morning, okay? All right, I've got half of you that have the answer. So we've got 1 more minute. I'm going to go over this. And then go ahead and open up your 0A.09 homework. If you did not do it or you need to make some corrections, do it real quick. It shouldn't take you very long, but let's do it right now while this is still fresh on your mind, okay? Alrighty, so which expression is equivalent to 10 plus 7r minus r squared plus negative 6r squared minus 18 plus 5r? The first thing I'm going to do is color or highlight my like terms. These are not in standard form, so it's important that you either rewrite it in standard form or use the colors or some way to organize them. So I'm going to start with my r squareds. So negative 1 r squared plus negative 6 r squared. Negative 1 plus negative 6 would be negative 7. So I would get negative 7 r squared. For the green terms, I have positive 7r plus, I'm using a plus sign, plus 5r. That gives me positive 12r. And then I have 10 plus negative 18. So positive 10 plus negative 18 would give me a negative 8. So that means C, or H, is your correct answer. Yay, okay, awesome. Before we go, if you did not write down the steps to adding and subtracting polynomials, here's a quick recap. Go ahead and write these down or take a picture with your phone. And then if you are having trouble logging into ClassKick, please send me an email so that I can email you back and we can troubleshoot together. Okay? There's no quiz for today. Today you're watching a video, and then at the end, I didn't add an extra homework assignment because I wanted you to revise the one from yesterday. But there is an Ed puzzle. So it's a video and it pauses every couple seconds and you enter in your answers there. So it kind of is a self-check that way. Okay? Jonathan, can you go check again because I wrote them out? Wait, are you talking about 0A.12? There are no exponents on those. Those are ones. So if there's not an exponent listed, you can, on 0A9. You can't see the exponents on which one? Question 2 on slide number 2 or slide number 3? Okay, it's negative 2x to the third plus 5x squared minus 5x plus 8. And then the second set of parentheses is 2x to the third plus 2x minus 7. Okay, I had one more question and then I'm going to let y'all go. How did I get negative 8 in the last equation? Good question. Let me go to it real quick. So positive 10, that came from this first set of parentheses. 10 plus, this is a negative 18. We have to include the sign that's in front. So 10 plus negative 18 would be negative 8. I'm taking away 10, moving towards the positives, but I'm still, this negative 18 was bigger. So it's still going to be in the negatives. Miss Nair is now doing Algebra 2, Grace. Good question. She's doing Algebra 2. All right, guys.